Welcome back to Conquering the JavaScript Interview. Today, we're going to add a new tool to your programming arsenal, the Gauss Summation Formula. And you might be thinking, wait a minute, math in my programming? That's not even necessary. I didn't become a programmer to do math, dude. Trust me, this is an easy one to understand, and it's a really cool mathematical concept that can give you a huge advantage in solving, well, any kind of algorithmic problem that has you sum a series of numbers from 1 to n. It is such a time saver, and it saves you time and headache once you understand it and know how to do it. And you'll learn a hopefully fun little piece of trivia, right? So for those of y'all that don't have any kind of math, like high-level mathematics background, like y'all, just did your core math from like American universities, which I know isn't a very high bar. For those of you that have any kind of math background, probably outside the States, or if you specialize in more mathematics in the States, then you probably know what the Gauss Summation Formula is, but we're going to get to it here in just a minute. Let's take a look at how that's going to relate to today's algorithm called find missing integer. We're going to write a function called findMissing that takes one argument, an array, which will be specifically an array of sorted integers, so whole numbers only, that will go from 1 to n. It doesn't matter how big our array is. In this case, it looks like it's an array of integers from 1 to 10. However, there is one specific integer missing from this array. And the point of our algorithm, our function here, is to return what the missing integer is. Meaning, if we have an array of numbers, 1, 2, 3, 5, 6, 7, 8, 9, 10, it should return the value 4 because that's the missing integer inside of this array here. Now, when it comes to arrays of this size, it's very easy for us, again, as humans with a brain, most of us, I'm busy destroying mine by working out and maybe getting into boxing and drinking alcohol, so I'm actively destroying my brain like an idiot, but it is what it is. We have the cognizance to look at this and go, yeah, there's just a 4 missing right there, dude. But again, how would this be done programmatically, right? We could just say, like, we have to look at every pair of numbers to see if they add up to some kind of value we expect to find what the missing one is. But once you learn this one simple trick that all mathematicians hate, I don't know, it's really straightforward to solve, right? So like I was alluding to, clearly that Gauss summation formula, and that's G-A-U, Gauss, German, right? Once we know this formula and how it's kind of derived, so like I said, there'll be some fun today. Today I learned type trivia in this video, and the actual code will be shorter than we think. It's actually very easy to solve, right? So Johann Carl Friedrich Gauss was a German mathematician and physicist who was basically a child prodigy, and between the years of like 1800 to like 1850 or something like that, he just did like discovery after discovery after discovery and contribution after contribution after contribution. He did a lot of complex discoveries, and like he was like, I think he was listed as one of the greatest mathematicians since antiquity, right? So he was straight ballin' when it came to math and physics. So, by all means, go find some podcasts or YouTube videos to watch to learn about the genius of Carl Friedrich Gauss, right? But how is he going to tie in today? Well, when he was a kid, he actually came up with a quick theory, a formula, if you want. Not even a theory, it's proven. It's a formula to sum all integers from 1 to n, right? And it's derived from a pattern that he noticed. So let's say we were like in some kind of mathematics competition, and we were told, hey, us as students, we're gonna have some space to write some comment here. Like, you have X amount of seconds to calculate the sum total of all values from 1 to 100. So, you start adding all these up one by one by one, like that, in order to get what we would call our sum of all those values, right? You just add one after another. And again, like, the longer this list of numbers gets, the longer that operation's going to take, because you have to add that n number of numbers together to get your sum. And again, with programming and calculators and all that stuff, that all seems very easy. But again, like back in the day when you just had like chalkboard and chalk, or 1800s, so definitely probably like, I don't know, pencil and paper, or like, I doubt they're doing hammer and chisel by that point. interpretive dance. That's how you do it. No. It will get more and more tedious the longer the set of numbers gets. So this kid Gauss was like, well, what if I do it in reverse order? Because technically it'd be the same thing, where it would be 100 plus 99 plus 98, and you're wondering how does putting it. Oh, I skipped one, didn't I? 98. I was like, something looks wrong about this one already. Let's remove it down. I want to be 3 on each side. Cool. Missing plus signs everywhere. There we go. Now that's official. Now we're professional again. Right? So he simply looked at it backwards. And again, you might be wondering, how is that going to help us? It's because he ended up finding a pattern between these things. Think of these things as columns that line up together. And he realized that if you look at it straightforwards, 1 to n, or n down to 1, he noticed that every column, right? So the column of s plus s gets us 2 times the sum. The first column is 1 at the top and 100 at the bottom, which he realized is 101. 2 and 99 are the next set of columns that go together, which, surprise, gets us 101. And I think you can see where the pattern begins to emerge here. 3 and 98 is indeed 101. So on and so forth. On this side over here, it's just the reverse. It's just all 101s. And it's like, okay, that's a cool pattern to know right there. And basically what the solution ends up being here is that it's going to be your total number, which is n, plus 1, which is 101, times n, which is how many times this number is going to appear, right? So this is our n, our number. So we can say, well, 2 times the sum of anything that starts at 1 and goes to n, in our case 100, is going to be n plus 1, multiplied by how many times it appears, aka how many numbers we have. So we could do something like this, right? N number of times n plus 1. So n is 100, n plus 1 is 101. That gets us 2 times the sum, and then divide both sides by 2, and we get the following. Boom. And that right there is the Gaussian summation formula that he found, again, as a kid, just by looking at the numbers in reverse, looking at a pattern emerging on the columns, and then just doing some derivation to QED, this right here, to say that to find the total sum of any set of integers starting at 1 and going to n, it is n times n plus 1 divided by 2 gets you the sum of those numbers. So this derivation we did here in mathematics, today I learned about Friedrich Gauss and this cool formula that we can derive very simply by looking at columns and patterns, is going to help solve this one lickety-split, right? Because if we know what the total sum of the numbers should be, all we have to do is sum what we have, subtract that from our total sum, and the difference will be the number that is missing. And that's all there is to it, folks. So again, look, today I learned, hopefully, for y'all, get in the comments down below if today I learned with this one and you're like, wow, cool derivation. I can't believe it took me back to math class. But again, knowing this is not just good for programming algorithm interview questions, but just in general, knowing how to find the total sum of numbers from 1 to n very quickly. Cool stuff. You never know when you're at a trivia night at a pub and this might come up or something like that. Or you're going to impress your friends by quickly figuring this out before they can or something like that. So you never know when that kind of stuff props up, right? So let's actually get to coding this sucker, and I'll show y'all once again. With that knowledge at hand, we should know it should be very simple. So I'll say const missing num is going to be whatever this function returns. We're going to console log it. You can see that my previous code is still running. I'm going to save this. I forgot to clear my console before the video, so amateur hour over here as per usual from your boy Luke. Let's clear that console out. We get undefined right now because this function returns nothing. So let's get underway here. So important tidbits to know. In order to know how long our array of numbers is, you're like, well, Luke, that's just our array length. But remember, technically our array of integers is missing a number from somewhere inside of it, meaning we need to add 1 to our length to get the true n length of our set of integers, right? So I can say const, we'll call it n equals our array length argument plus 1. So remember that plus 1 represents the missing integer we have in this set of numbers, right? Now, just like we saw when we derived this formula, all we need to do is get const total sum equals, we'll do a set of parentheses for n times, parentheses, n plus 1 divided by 2 gets us the total sum of whatever the value of 1 to 10 truly is if all the numbers were there. That's what this represents. It represents the total sum of 1 to n as if that missing integer was there, right? So from there, we have to calculate what the sum of our current array is. We can do that in a couple different ways. Let's do it longhand first. We're going to call it the array sum, and it's going to be a value of 0, and we're going to simply iterate through each element of the array and add them together. So you can see where different implementations might have different shorthands for our for loops here. Let's say we're doing this by the books. Traditional for loop, and we simply say our array sum will be concatenated or added with whatever each of our elements is. As we loop through our input array, that will get all those values up together. And then all we need to do is return our total sum minus our given array sum. And the difference between them is our missing number of 4. And there you go. So like I said, this one is very beginner friendly if you have a little math lesson beforehand. And knowing this is, again, great party trick. You never know. If you hit this up in trivia or a party trick at some point in the near future, please come back to my comments and let me know, because that just make my day that we can dork out as math nerds and have it benefit us somehow. Right. So, like I said, other ways to think about this, we could also do shorthand form. Right. I can learn how to write const ella or num of array, right? So we can say const num of this array. So we can shorthand our code a bit further to make sure the code looks cleaner as well. But if you're noticing something here, this right here, this code we're running is the classic accumulator of a reduce function. So this is where I tend to start showing some of my more beginner students the cool uses of some of the more advanced array methods. Like, we're all very familiar with for each and that one especially, but again, like, throwing in some of the more advanced array methods is a cool way to show that you know your stuff and can handle some more advanced concepts. So this right here is basically what a reduce function would do for us. It would go through each element of the array and accumulate some tally for you. So let's see how this would look should we convert it to a more advanced array method. It will also return some kind of value here to us. So we're going to call array.reduce. It is going to be an array method, aka a function. It itself takes a function to run some code. It takes 2 arguments, unlike a lot of our other base array methods. Argument 1 to reduce is our callback function, what's going to be running on every single element of the array as we reduce through it. And then we have something called an accumulator. Now, this accumulator, like if you're collecting a series of characters, then a string would work. But since we're counting an array of numbers, this is where our starting value for our accumulator, aka what eventually array sum, is going to be, which is going to be a fat goose egg, big old 0. Because we're counting a series of numbers, I'm going to initialize my accumulator, my total, my tally, whatever you want to call it. I am going to initialize it with a value of 0. So this is basically where you initialize what your accumulator is going to start at as the code begins to run, right? So we say we have our accumulator. That's what that is going to be. And then I think we have our element here, or like our current value. This is our accumulated value, I'm pretty sure, is the order of arguments. Yeah, we're going to use this advanced one, and I'm going to go ahead and mess it up for you guys, right? Right, so let's go ahead and simply add these 2 together, because this should represent our tally as we go forward, and this represents our current element as we go. We need to return something from each of these callback functions. So we're going to say return our accumulator plus our current, and have it just keep on moving forward. So this is going to go through each element of the array and do exactly what we saw just a moment ago, and we get an answer of 4 once I save and rerun this file. So there you go. That's a cool way of using a more advanced array method to solve this one. For some more ES6 shenanigans, we can always drop the curly braces, drop the keyword return. I like to wrap, even though this is a single line return, I'm going to wrap mine in a series of parentheses like that as well. And what we can do now is have it all moved on one line to make it ultra fancy here, and we still get our value of 4 because this reducer is still, that's a different thing. This reduce method is still working as it should with our ES6 shorthands to really strut our stuff around. It looks like my formatter dropped the parentheses. I personally prefer them when it comes to stuff like this, but my formatter has other rules until I go and change it, right? So in summation, I guess pun intended, the Gaussian sum formula of finding the sum total of anything of 1 to n in ascending order of integers is a very handy little trick to count that series of numbers, and knowing how to do that trivializes this particular and classic algorithm question you will get asked. I feel like this is almost like just a crap test to see if you know this trick or not. But nevertheless, you know, now you know, so hopefully if you do encounter it in an interview, you won't feel stumped by it. So yeah, that'll be about it for this one. Oh, it has a big O notation. I've been trying to include that more and more regularly since I've seen comments of people mentioning complexity and things like that. This one has a big O implementation complexity of n, right? We only loop through the array one time with our reduce or our traditional for loop or even our for of loop. Those are all just one loop that iterates over all of the elements of the array at least once, which means the bigger our input array gets, that's what increases our complexity, hence so we get a big O complexity of just n, right? This is because the most time-consuming operation of the function is that reduce or loop function, which iterates over the input array to calculate its sum total elements, and the input array has a length of n minus 1, so the time complexity of this operation is proportional to the size of the input array, right? So like I was saying, the bigger the input array gets, the longer it's going to take to loop everything, hence we're going to do a big O of n, say nice linear line, right? All the other calculations like the total sum and the n, those are nothing, right? Those things have a constant complexity of 1 just instantly, right? It doesn't depend on they don't depend on the input size of the array. So yeah, as always, thanks for watching. I hope you found this video helpful in our collective journey of becoming better developers. If you enjoyed this video, please consider giving it a thumbs up and consider subscribing to our channel for more videos like this. And I'd love to hear y'all's thoughts on this algorithm. If someone wants to get fancy, show me how to do it with bitwise operations. 'Cause I know how to write it. And I could probably half-ass explain it to y'all, but if someone in the comments wants to show how to do it with bitwise with a code pen and maybe an explanation, that'd be pretty cool. So get in the comments down below if you are competent in bitwise operations and can maybe show me how to do it with that. That'd be awesome. Remember, constructive and positive comments are always welcome here, and let's keep the discussion going and help each other improve our coding skills. So thanks for tuning in, and I'll see y'all in the next video.